Alright, this is assignment 10.4. When it comes to opposite and adjacent, opposite means you go across the triangle. Adjacent means it's right next to it, but it's not the hypotenuse, because the hypotenuse has its own special name. So if this is the leg opposite from A, here's A over here. The opposite side is going to be over here. It's going to be side BC. You can give me that, BC, or because it does have another name, like a nickname of the lowercase a, if you call it A, that would be the distance between point B and point C. That also counts. So second one, it says name the leg that's adjacent to A. So now if we're still at A, but we're looking for the leg that's next to it, it'd be this leg right here from A to C. So once again, if you call it AC, or if you call it lowercase b, you're still talking about this leg that goes from A to C. This is name the ratio A over B. So if I'm going from A to B and I want to use tangent, because that's all we've done so far is tangent, then A to B, if the top one's supposed to be opposite and the bottom one's supposed to be the adjacent, so this is the tangent of A. Over here it has B on top and A on the bottom, so B is supposed to be your opposite. The angle that is opposite would be capital B, so you're going to go tangent B. Number 5 says find the tangent of A, write your answer as a fraction in simplified form or as a decimal. So if I'm going just from angle A, I'm going to put a circle to emphasize where I'm looking from. If I'm looking from A, opposite over adjacent would be 3 over 4, or if you did a decimal in the calculator, it's 0.75. Then over here we have from A, opposite is 2 square root of 3, and adjacent is 2. You cannot give me this as a final answer because you still need to simplify this radical. The 2 and the 2 cancel each other out, so it's the square root of 3. If you gave me the decimal form, 2 square root of 3 divided by 2, it's going to give you 1.7320500808. We have to go 4 decimal places for these, so 1, 2, 3, 4, we're at the 0. 5 next to it makes it go up, so it's 1.7321. So this would also count as the answer. So over here we have these two, over here we have those two. Number 7, from this A, your opposite is the 8, adjacent is the 3. You can't reduce this anymore, so that's a good answer. Or if you did it as a decimal, 2.6667. Because we want 4 decimal places. So after 1, 2, 3, 4, after that 4th place, the next one is going to make this go up. So it's 2.6667. On these problems, it's asking you for 2 different answers. So it's asking for S and R. So if we're looking from S, so the tangent from S is going to be opposite over adjacent, 5 over 4. If you do that from angle R, now your opposite is going to be the 4, and your adjacent from R is going to be the 5. On number 9, for the tangent of S, from here your opposite is 12, your adjacent is 5. And for your tangent of R, from here your opposite is 5, your adjacent is 12. Number 10, the tangent of S is going to be opposite over adjacent, 7 over 4. And then the tangent of R is going to be 4 over 7. This says use a calculator, and it specifically says 4 decimal places. You have to do 4 decimal places. So if it's the tangent of 8 degrees, the calculator is going to do all the hard work for you. You just go tangent of 8. Don't forget to close parentheses because it's good form. 4 decimal places, 1, 2, 3, 4. That 5 is going to stay a 5, so it's 0.1405. Next one, tangent of 17. So you're going to go tangent 17. 3057. The next number is not going to make it change, so it's going to stay 0.3057. Number 13, the tangent of 32. Tangent 32. It's 0.62486. That 6 is going to make this 8 become a 9. So it's going to be 0.6249. And then the tangent of 50, the 7 is going to become an 8 because that 5 is big enough to change it. So it's going to be 1.1918. Last three problems on the front. It says write two equations you can use to find the value of x. Do not solve the equation. So if we're going from this angle and we're using tangent, because that's all I've shown you so far, the angle goes right next to it. And then you're going to go put the fraction up, the opposite 3 over the adjacent x. And from this equation, you would work the problem out and find the x. It says do not solve the equation, so we'd stop there. Now the other way you can do it, if instead of going from this angle down here in the bottom left, you want to go from this top angle. Since we know that all triangles are 180, there's already 90 here. So if you subtract 25 from 90, you're left with 65 degrees on this top right angle. That means you could go the tangent of 65, and then you would go the opposite is now x on top, and the adjacent from 65 would be 3, so now that goes down to the bottom. So those are the two different ways that you can make an equation that will help you solve for a missing side. Number 16, same thing. So I can go tangent of 54. And if I do that, my opposite is x, adjacent is 5. And if you're going in reverse and you're finding this other angle, you'd have to go 90 minus 54. That's 36. Then you would go tangent of 36 is, and then you'd go opposite over adjacent 5 over the x. And that would be those two answers. And then this piece, from this angle, your opposite is 4, your adjacent is x. And then if you're finding this angle up here on the top left, you'd go 90 minus 28 is 62. And you'd go tangent of 62 is, and then from here your opposite is x and your adjacent is 4. So those would be your two equations if you were working it out. On the back side, it says what kind of ratio is the ratio of the length of the two sides of a right triangle? Well, the notes were tangent, so that's the answer, the tangent ratio. Number 2, in a right triangle, the ratio of the leg opposite an acute angle to the leg adjacent to that angle is the blank of the angle. That's also going to be the tangent of the angle. And number 3, the tangent of angle A is written as, so if we look right here at this example, if we're going the tangent from A, I'm just going to put opposite over adjacent. Okay, for number 4, it says find the tangent of A as a fraction in simplified form or as a decimal, round to 4 decimal places if necessary. So if we're going tangent of A from here, 6 is your opposite, 7 is your adjacent. So for the tangent of A, it'd be 6 over 7. If I was doing the decimal on that, I'm not going to write it down, but just so you see it on the calculator, it would be 0.8571. Tangent of A from here, the opposite is 3 square root of 3, and then adjacent is the 3. Again, you have to simplify just like on side A, so these 3's would cancel each other out, so your answer would be the square root of 3. Again, if you want to do it on the calculator, square root of 3, you get 1.7321, because the 5 is going to make the 0 go up. And then number 6, from A, your opposite is 14, and your adjacent is 48. So you can let the calculator do the reducing for you, or you can divide by 2, because they're both even numbers, you can divide them by 2. Either way, you have to give me the simplified fraction, so it'd be 7 over 24. That would be your final answer. Number 7, it's asking for P and R, and it's asking as fractions in simplified form or as a decimal, rounded to 4 decimal places. So if I'm going with the tangent of P, I'm going to put opposite over adjacent, 5 over 3. If I do the tangent from R, then I'm going to go opposite over adjacent. Now it's going to be 3 on top, 5 on the bottom. For number 8, tangent of P, opposite over adjacent, 16 over 12. And I can reduce that. They can both be divided by 2. So I get 8 over 6. 8 over 6 can be divided by 2 again. So I get 4 over 3. So there's my tangent for P, and then for the tangent of R, I go opposite over adjacent, 12 over 16, And since I already reduced this, and I know it's the same numbers upside down, I don't even need to think about it again and reduce again. I can just put the 3 on top and the 4 on the bottom, and that will be the tangent of R. Over here, tangent of P would be opposite over adjacent, 9 over 40, and then the tangent of R would be opposite or adjacent, it would be 40 over 9. Over here it says write 2 equations you can use to find the value of x, then find the value of x to the nearest tenth. So this one we're actually going to go all the way through. So from 26, my opposite, I'm using tangent, 26. My opposite is 6, my adjacent is x. If I wanted to do the other equation, I would go tangent of, and I'd go, this angle up here would be 90, 80, 70, 64. I'd go tangent of 64 is opposite over adjacent, x over 6. Since I need to solve, I'm only going to do one of these. I'm going to go ahead and do this first one. When the x is on the bottom, you're going to put 6 divided by, because the x is on the bottom, and then the tangent of the angle. And the calculator is going to do the work from there. So 6 divided by tangent of 26. And this is a distance you can round to the nearest tenth, so that'd be 12.3. If you were doing this equation instead, since the x is on the top, it's almost the same thing, except you're going to put times instead of divide, but it's still going to be the number from the leg. So it's still going to be the 6 in the front. And then you're going to go with multiplying instead of dividing. And then you're going to put the tangent of the angle still. So this time the angle is 64, I'm going to change that. And it gives me the same exact answer. So either way works. On this one, same process. So I'm going to go tangent. From this angle, I have opposite over adjacent. So the tangent of 60 is going to be x over 4. And if I work this out, remember that it's on top, so it's going to be multiplying. So you would put 4 times the tangent of 60, and you'll find out what the answer is. Or, if you're going from this angle, 90 minus 60 makes this bottom left angle 30, and you'd go the tangent of 30 is going to be opposite over adjacent 4 over x. Now the x is on the bottom, so if you're doing this one, you're going to divide. So I'm going to use this top one because I did it first. So I'm going to go 4 times the tangent of 60, and I get 6.9. If I did this one, it would be 4 divided by the tangent of 30, and I'm still going to get 6.9. Number 12, if I'm going from the 70, my opposite is 9, my adjacent is x. Since that's how it was already set up, I'm going to go ahead and finish this one all the way through. So this is going to be x is on the bottom, divide. And go 9 divided by the tangent of 70. And I'm going to go on the calculator. 9 divided by tangent of 70. And I get 3.3. If I was doing it from the other angle, over here, 90 minus 70 is going to make that 20 degrees. And I would do tangent of 20 equals, and I'd have opposite over adjacent. And I would do multiply instead of divide. So I would go 9 times the tangent of 20, and I'd still get to 3.3. Now the last part, this is not something that's tested, but it is how tangent is used outside of a math classroom. So it's a really good example, not because you're tested on it, but because you can see where it actually works. It says use a tangent ratio to write an equation to find h. So if you're looking for the height of this building, and there's no way for you to measure how tall it is, you can measure across the floor a distance going this way, and then you can measure the angle. There's tools out there that'll do that, that'll measure the angle of elevation this way. And with that, you'll be able to find your h. So it's still a right triangle. We can still use tangent. These are still the legs. Tangent of the angle, just like before, equals the opposite, h, over the adjacent, 60. So that would be your equation. Now it says solve it. So h is on the top, variable's on the top. That means multiply. You go 60 times the tangent of 50. So 60 times the tangent of 50. And you get 71.5. And we're talking feet.